Hello everyone, today we would be discussing the first problem of core forces think cell round 1. Problem A, maximize the score. It says there are two and positive integers written on a whiteboard. Being bored, you decided to play a one player game with the numbers on the whiteboard. You start with a score of 0. You will increase your score by performing the move exactly n times. Choose two integers x and y that are written on the board. Add minimum of x and y to your score. Erase x and y from the whiteboard. Note that after performing the n moves, there will be no more integers written on the whiteboard. Find the maximum final score you can achieve if you optimally perform the n moves. Like let's start with the samples first. Like first sample is 1 and 2. First sample is 2 and 3. And if you notice, we don't really have any choice over here. Like this would be the only pair we would choose, and the score would be minimum of this, which would be 2. Second sample is 1 1, 1 and 2 and 1. In this case also, if you notice, we don't really have a choice. One of the pair must be 1 and 1 and the other pair must be 1 and 2. You can either choose 1 or 2 in the first turn, or you can choose 1 or 2 in the second turn. And in this case the minimum would be 1. In this case also the minimum would be 1. So overall the final answer would be 2. And like samples are not really good over here. Like the third sample says all of the numbers are 1, so we don't have any choice over there as well. Like I start with like the one way to solve these kinds of problem is like let's first sort the numbers because we are asking maximum. There is no reason to, but let's just do it to make my reasoning next time next of the reasoning simpler. Let's say the sorted order of numbers is b1, b2, b3, b4, then some bi up to b21. My claim is like in the optimal answer it would always be the case that b1 should be paired with b2. And the way to see is would be like we choose some other pairing and then we try to prove that if we try to make b1 and b2 as a pairing, we would get a better result. For example, for a minute, let's assume like b1 is not paired with b2. Then b1 is paired with some bi, which is greater than where bi is greater than b2. This is essentially because b1, b2 are the shortest number, so b1 is the smallest number, b2 is the second smallest number. And because like smallest number and some second smallest number b2 is paired with some smallest number bj. Here also bj would also be greater than or equal to second smallest number. Like equality holds when the second smallest number repeats multiple times. And if we compare the score over here, like in this case the score is b1 and in this case the score is b2, because we have to take minimum of both of the pair. And overall score when b1 is paired with bi and b2 is paired with some bj, the overall score is b1 plus b2. And like now let's do one thing. Let's see what happens if we try to swap bi with b2 and like all the remaining pairs remain the same. Then our pairing becomes b1 paired with b2 and some bi paired with bj. Here the score would be minimum of both of them, which would be b1, like b1 is the smallest number. And here the score would be minimum of bi and bj. And both of these number are at least b2. So overall score over here would be b1 plus minimum of bi comma bj. And because both of these numbers are greater than or equal to second number, like this cost is greater than b1 plus b2. And if we see like in case like smallest number is not paired with second smallest number, then we can try to swap it with the other pairing where the second smallest number is involved, and we would get a better cost over here. Like if you see like here the smallest and second smallest numbers are paired, and in this case the smallest and second smallest are not paired over here. Then by just looking at the numbers which were paired with second smallest and second smallest number by swapping something, earlier our score was b1 plus b2, and now our score is b1 plus some number which is greater than the score we would have got. So like this gives us an idea in the optimal pairing, like where it's the case like b1, b2, b3, b4, so and so on, we should pair the first smallest and the second smallest number. using which add score b1 and then try to find the answer for the remaining part array. And even for the remaining array, like again we can choose the smallest and second smallest number and like add that to the pairing, and then we can try to find the remaining part. So overall in this case our final score would be if b1 b2 b3 b4, like if this is the sorted array, then our score would be b1 plus b3 plus b5 plus b7 and so on. And this would essentially come when like we pair smallest and second smallest number, third smallest and fourth smallest number, fifth smallest and sixth smallest number, seventh smallest and eighth smallest number. And we have already proven that in the optimal pairing, like the best case scenario we have, like it's always better for us if we pair the smallest two numbers in the first move and the second, third, and continue the remaining part in the remaining array. Now jumping on to the code for this problem, first I have taken all the numbers as input. Then I have sorted all the numbers in the increasing order. Now I am adding pairs in the jump of 2. Like P1 is the number which would be remain after removing all the numbers which are before I. And now I take 2 of this pairing and add minimum to the answer. Like this minimum is essentially just P1 only. And then we print the final answer and it gets an accepted verdict.